Good morning, everyone. My name is Keith Durbin. I am the Chief Information Officer for Metro Government, and I'm also the Director of our Information Technology Services Department. And I'm very, very pleased to welcome you to our ITS Collaboration Center. And is this our inaugural day today? Our inaugural day today. Many of you know our Chief Data Officer, Robin Mace, and one of her key responsibilities here at Metro is working and striving both with our internal staff within Metro, but also the community to work to inspire and really instill a culture of the use of data within government and in the community at large. And so this is a real opportunity to get that going on a sustainable, long-term basis. So this is the inaugural, but it's by no means the last day today that we're gonna have. This and the data culture we're looking to instill fits right into kind of the grander plan that we have for how technology and data can really impact Nashville and Davidson County going forward. 2 years ago, a little over 2 years ago, the U.S. Department of Transportation put out a call for proposals for cities, mid-sized cities, for a $50 million grant to how they can transform their transit infrastructure using data. 80 cities across the country applied to that, Nashville being one. And while we did not win, Mayor Berry at the time took that opportunity to say, you know, we have not looked closely at how we can use technology to forward our goals and meet the goals of our community. And so she asked me to establish a task force to basically look at how smart cities technology could help us meet our goals. That group was called Connected Nashville. And over the 2 years since then, we had a 75-person working group from across the community, across demographic groups, across industries, across government levels, that did a couple of things. First off, they looked at vetted community plans. So things like Nashville Next, Let's Move, the Livable Nashville Plan, scanning those documents for goals that had been presented and vetted to the community that we could enable and expedite through the use of data and technology. Once they had done that, those working groups then took that and looked globally to see, based on those goals that we needed to be met, how were other cities around the world doing that? What technologies were either in existence or on the cusp that could help with those things? And at the end of the day, we came up with a plan that was submitted to the community for community review last fall, called Connected Nashville. And after 2,000 community touch points later, we presented the final version of this plan to Mayor David Briley yesterday morning. And the results of that, you can see at a very high level, are what we call our smart city mandala. So for a metro government of 60 departments and agencies, the working groups distilled lots and lots of ideas into 21 individual strategies. And the individual items that I've got noted were the top 5 that were subsequently prioritized by the community. And in the order that they were prioritized, and some of this is going to sound familiar. Number 1, enhance our transportation corridors. Number 2, protect our natural resources. Number 3, embrace green building and energy efficiency. Number 4, assist residents in accessing affordable housing, And number 5, increase digital literacy and innovation capability. Then the mayor added a 6th one in, and this is close to my heart, enhance the parking experience. And probably some of you here as well. So these 21 strategies are detailed in here, and not only the strategies themselves, but with each strategy, specific strategic activities that departments and agencies of the metro government are submitted to them to take and move forward with. That doesn't mean that the work that metro government is doing has stopped by any stretch of the imagination. We also have included, and the copy of it is up here for you, a listing aligned with the categories of the mandala over there of existing or planned and funded basically, projects of a smart city capacity, such as starting the transportation and mobility. You'll see a lot of things that relate to the transit referendum that's going to pass next week. Some of those not started, others are in works now, such as our Public Works traffic signalization program, things like the Nashville Business Portal that the mayor's office is working on. Hub Nashville, which any of you have been paying attention, last summer we released the first centralized local government request system. You can call 311 or go to hub.nashville.com and submit a request or an issue. You don't have to worry about who it goes to, don't have to worry about knowing a council person, it'll get routed to the right person. And since then, as of this morning, 63,000 requests have been processed. Furthermore, next week we'll be releasing Metro's first Hub Nashville mobile app as well, so be looking for that and you'll be able to use it. So the commonality between the things that we are doing and we're planning to do and the things we're doing today is the underlying infrastructural item is data. Each of these projects is going to produce and is already producing in most cases tremendous amount of data. And we need to make sure that we have an organization that is primed and ready to use that data to help make better decisions for our community. So all that to say, to sum it up, I'm very glad you're here. If there's anything that we can do to help facilitate for you as Metro Central IT Department, please make sure that I'm aware of what you need, or Robin, and I very much look forward to working with you in the coming years. And so thank you for being here once again.
Thank you so much, Keith. Good morning. Thank you all so much for coming. This is a really exciting day for us, me especially, kicking off the first of what I hope will be many and a much beloved institutional practice of our data champions. Day to Day is going to be a space and a time right now, once a month on Fridays, to have fun, but with thought and purpose-driven work on data to learn and to collaborate and to experiment in our very own Metro Lab in spaces that have been tailored for promoting collaboration. Before we get started with our excellent presentations, I just want to do a little bit of housekeeping. The restrooms are outside the double doors that you came in at the top of the stair landing. You may notice that we are filming, so I'd like to ask you to turn your cell phones off if you haven't already. As we break close to 12:15, I will point out again the green cards on the table. No such thing as a free presentation. I am going to solicit a few of your ideas about what you think great topics or great speakers for Metro Data Champions monthly meetings or our monthly data days. And with the brain trust we have here, which is clearly a microcosm of Metro's data ecosystems as well as larger consolidated Nashville-Davidson County data ecosystems, because we have several members of our commercial and civic tech communities here. I'd like us to collectively start to think about how to structure, facilitate, and engage with opportunities to use data widely with the whole community to enhance our digital and data fluency. And in fact, one of those opportunities is coming up. I want to shout out to Alex Curtis, who's here from Nashville Tech Council, and let everybody, all of you data lovers and doers, know that on Monday is the deadline for the Analytics Summit presentations. So if you have an idea, Alex would be a great person to talk to about it, and I really encourage you to submit. So again, we very much appreciate your being here, and without further ado, what I'm going to do is introduce all three of our speakers, and they are just going to have a continuous sort of presentation. At the same time, if you have questions you'd like to ask, we will entertain limited questions while the talks are going on, because obviously it makes more sense to ask your question when you think of it, but we don't want to disrupt too much from the flow of the conversation. However, at around 12:15, a few minutes after the presentations are over and some of the ending questions are over, we're going to have a 10-minute bio break, and then those of you who can come back please do come back into this room. There's a select group of people for whom they're working for their lunches, and those lunches at 12:15 will be out on that table with your names on them. So please pick those up and come back. And for those of you for whom we were not able to provide lunch, grab a bagel and come back and sit with us and talk about data. So, Mary von Valkenburg has spent many years working for the state of Tennessee in various roles. She loves being at the crossroads of technology and working for the greater good. About 6 years ago, she had an epiphany about the importance of data and now gets paid by the Nashville Software School to play with data and facilitate learning in others who share that passion. Eric Lancaster is a former high school university math instructor who decided to dive into the world of programming. He works as a software engineer in the business intelligence team at Ingram Content Group and is currently completing his coursework at Nashville Software School to learn the finer points of data science and machine learning. Mahesh Rao received his PhD in biological services from Vanderbilt University before becoming a postdoctoral research fellow at Vanderbilt University Medical Center. Throughout his research, Mahesh has studied regeneration and development of the retina, and he is transitioning into data science with the help of the Data Science Boot Camp at the Nashville Software School. So I'm going to turn it over to our speakers, taking just a moment to readjust the microphone so we can pick them up on the...
So thank you for having us here today. We're very excited to talk about our data science program at the Nashville Software School, our collaboration with Metro Open Data. Data is, for me, a kind of magic carpet that lets me go new places and discover new things. And Open Data encourages us all to take that ride. And as a resident of Nashville, I'm a huge fan of what you all are doing here. So our agenda for today looks like this. I'll give you an overview of the Nashville Software School, our data science program, and the property standards violation data question that we worked on. Evan will then walk you through the process of cleaning and exploring the data, as well as the process of recategorizing the violations to types that could be classified in the open data set. Mahesh is going to show you new insights that we got as a result of the recategorization of the data, or the violation types rather, and then I'll close it out with an example of how data science could be further applied to this data set to deliver a meaningful, actionable product. So the Nashville Software School, if you're not familiar with it, it's a community-focused nonprofit that was founded 6 years ago in order to open the door to new tech careers for people with motivation and aptitude, regardless of their financial means, and as a way to grow the tech workforce in Middle Tennessee. We make an extra effort toward opening those doors for groups that have been traditionally underrepresented. Web development and now front-end design and data science programs are offered by NSS. To date, over 25 classes have been completed, and I should have updated this, by more than 600 students. And those graduates have been placed with more than 200 employers at a rate of better than 85%. A simple definition of data science is applying tools and techniques to get insight from data. And we usually see those tools and techniques coming from the intersection of three areas: statistical knowledge, coding skills, and domain expertise, or knowledge about a particular subject area. And the data science process looks like this: understand or formulate a question, get data, clean data, perform exploratory data analysis, build a model or test a hypothesis, communicate the results, and then, if warranted, build a data product. And so we teach all of this as part of the boot camp. And we do this at NSS with project-centered skills practice. We use what's called a flipped classroom. Instructional videos are completed on students' own time, so we can use classroom time for hands-on practice. We teach Python and R, and we prepare students to work in data-centered careers. These are the data sets that we have worked with so far in the first cohort. And you'll notice that Metro Open Data was the second data set that we worked with right after the super clean and easy UN data. So I asked Robin to help us by formulating a data question that would let us apply new skills to an open data set. Ideally, a question whose answer would be of use to Metro Nashville. And this is the question, actually that's a screenshot from the GitHub README file for the project. First, we would attempt to collapse the number of violations categories down to 20 or so. Then we would apply those categories to the property standards violations data set, the open data, in order to identify which violations in that data set fell into which of the new categories. And finally, we wanted to showcase the insights that resulted from the new categorization. Evan's going to tell you about the first two steps, the cleanup, coming up with the new categories, applying them to the open data, and then Mahesh is going to share some of the things that came out of what we did.
I'm going to swing around here so I can see who I'm talking to.
Do you want laser?
Sure. So I'm Evan Lancaster, and as Mary said, my goal is to walk you through my code and really just my thought process of being able to go from over 900 laws down to 15 to 20 categories, and then be able to take those categories and go to actual code violations data, and for each violation say, what kind of category should this fall into? So you're looking at the beginning of my code, and we used Python coding language to do our analysis. And this is a Jupyter notebook. For those of you not familiar with Jupyter notebooks, it's just a way for you to be able to run code in snippets. So you can run a little bit of code and see the output, and then tweak it if you need to, and then you can run the next block of code that builds upon the previous lines. So it allows you to be able to troubleshoot and to be able to do some exploratory analysis kind of on the fly. The other reason it's useful is for things like this. When you want to do a code review, it allows me to be able to mark up different sections and highlight things and with bold fonts and headings and things like that, so you can kind of see my thought process instead of looking through my rat's nest of code and trying to interpret all that. So here's our code, and it begins with just importing a bunch of Python packages. They're just code libraries that people much smarter than me have written. There's a lot going on with those that we'll talk about a little bit later, but right now we're just pulling all that in. And the second thing we did was we went and found the code book of laws in a spreadsheet that was given to us, an Excel spreadsheet. And we had to do some cleanup on that. So I'll show you that data now. It looks like this. You have columns for violation ID, which is just a numerical code. You have an org ID. That's always 1, and frankly, I don't know what that represents, but it was always 1, so I just ignored it. You have violation type, which is, I believe, just the character string that was the code used by, I assume, Metro's systems. You have a little more human readable version of that in the violation description. And then over here you have the violation text, which in most cases actually refers to the law or the code on the books. And the books, when I'm talking about that, we're talking about both Tennessee state laws and also Metro Council city ordinances as well. And I say it most of the time references those because as you start to get toward the bottom, things get interesting. You also have some other columns here. There's a remedial text that I believe is just legacy abbreviations from maybe prior systems that Nashville had used. So I ignored those, and then you have some other columns that really are either nulls or not useful for what we're doing. So we had to clean all that up. Beyond just that, as you kind of start to scroll down, you start to see some things become problems. Things like not recognizing what cells are even supposed to have in them. So there's a lot of dirty data that's there that had to be cleaned up. You also see as you get toward the end, you start to see a lot of just completely blank rows, but they're not showing up as blank, so we had to drop all those. And then even below that, you see there are footnotes at the end for some of the laws and codes. So we had to clean all that up. And so that's what this snippet does, is it reads in the Excel from this file. It picks just those 4 columns we needed: the ID, the violation type, the violation description, and the violation text. It picks up all those columns and names them and sets their data types. And then we drop all the null values so that we don't have any of those blank rows. And we set the index on it so that we can refer to it by the number if we need. And then we set everything to uppercase so that we don't confuse the program with case sensitivity issues. So once we brought all that in, the goal was to categorize these, right? To be able to take those 900 plus rows, which, by the way, you can see here how Python recognizes it now. So it's a much cleaner data set. You see everything's capitalized. And as you go to the bottom, you can see, if I scroll a little further, you can see now there's only 788 rows to worry about. So we've weeded out a good portion of it already, just from getting rid of those blank rows. So the next thing I did was I just added a placeholder column for being able to put in our categories. So you can see we've got a new column here and it's all blank, but we're going to be filling that in here in just a little bit. So we want to add new categories based on certain criteria, and this is where the fun really began. If by fun you mean me crying in my bonus room at the task at hand, because it's pretty overwhelming to look through 700 and something plus anythings and try to make sense of it at one time. And so really Mary was the one who, during one of our classes, pointed out something that she noticed that really helped me out of knowing where to start. Because the good news is, if you don't know where to start, then anywhere is as good as any place, right? So you might as well just pick a place and go with it. And so what she noticed was, starting here, for instance, you'll see in the violation type, they all start with BB, right? And so some of you guys who maybe have worked with this data, you might know where this is going, but for me, I had no context, so I didn't really know. But Mary pointed out, when you look at those, a lot of those, in fact, all of those are referring to alcohol, right? And so you've got alcohol ordinances here. And then you'll look here and you'll see those are, you know, from Metro Council, it's actually referring to all these things having to do with alcohol. And so we realized that, okay, if I want to make a category, right, let's just take as big a chunk as I can, because if you look back over, I mean, there's a ton of those. Right? And so that lends itself to making itself a category. So I said, okay, well, I'm going to take and make that, I forgot I can't do that. I'm going to take anything that starts with a BB in the violation type and make that alcohol. Well, as I looked further, I realized that that was a problem, because as you scroll on down, some other ones, right, that have nothing to do with Metro Council, these are the Tennessee Code annotated laws, those also relate to alcohol. And so I had to, what I did was I took, because I wasn't familiar enough with Python at the time, and I was more familiar with Excel, if you can believe it, because I'm pretty bad at Excel too. But I took this and I said, okay, I gotta weed some stuff out. So I said, well, you know what? Let's just take this guy and let's apply a filter, and you know, if it starts with BB, then that's good for me. And so we applied that, and so that now you can see everything is just filtered to that. And so then I took all that and said, okay, let's see, I need a way to designate that that is spoken for. So I just color coded it red and said, these are spoken for, like these have a category applied to them. We'll worry about what it is later, but for now, because I really want to just ignore those and look at the rest. And so then once I take off the filter, the color still remains, and so I can see which ones I need to look at next. And then if I wanted to, I could even come over here and apply a filter and ignore the colored ones. Right, so now those are, sure. So now those are out of the way. So I didn't have to worry about them anymore, and I could deal with the next group. When I did that a lot, I had to realize that I had to make more colors, which is funny because I'm also colorblind, so this is like a horrible idea. And especially when you realize that this is what you end up with, it's just, it's just a rainbow of color coordinated things. And it all looks like grayscales to me, but really, at the end of the day, all that matters is the ones that were white, those were the ones that I hadn't dealt with yet, right? So I just filtered all the colored ones out, and then I deal with the next group. It's a very, very brute force, rudimentary, it's not best practices way at all of handling things, but it got me moving in the right direction. So when I did all that, coming back to the Python, that made me realize that, okay, I need more than just BB for alcohol. I need also TCA 57-5. That's another alcohol-related code. And then as I got to digging in deeper, I realized, well, alcohol violations really kind of fall into one of two camps. You've got those relating to just permits, and then you've got, well, everything else. And so I decided to draw those distinctions and make two different categories here. And so you can see in my code, I've got, if it's got the violation type has a BB at the beginning, or if the violation text field has TCA 57-5 in it, if it's got either one of those and the description contains the word permit, then that's the category for alcohol-permits. And you can see here when I applied that, now we've got all those violation categories assigned for all the BBs, and then if we scroll on down, you see all the TCAs as well, TCA 57-5s. So we applied that category. Once we did that, we were able to come down and designate the other ones. And so we have, if it starts with BB or if it starts with TCA 57-5, either one of those, and it doesn't, that little tilde there means doesn't contain permit, then that's everything else. And so we were able to apply that, and you can see that as well here. So I'm not going to walk you through all 18 categories of how I came up with each one, but I do want to just very quickly point out a couple of them to you. The ones like waste, right? You can see here, there's a lot of different ways you can describe waste. You can describe it as rubbish, garbage, junk, sanitation, dump, right? I mean, there's a lot of different flavors here, so I had to account for all those. And this is all very much trial and error. You're seeing the end result, and it looks like I just came up with all that at once. That's hours of work just to come up with that list. So once we got all that, then you could see, it was starting to apply all these categories the way it should. And so that was good. The other one that was kind of interesting was signage. There are signage laws on the books as well, things that have to do with signs or prohibited signs or banners, but not things that have to do with consignment, right? It was, when I didn't apply the con on the front, it was picking up things like consignment sales, which have nothing to do with signage. So I had to strip that out by saying ignore the things that have con in it. And so apply the category of signage to that. And so you can see, I mean, there's tons of these, right? We could go through these code snippets, but we're not going to. And every now and again, I would say, I wonder how I'm doing. And so I would look and see what kinds of violations were left that had not been categorized yet. You can see the blank column here. And so I would just look and see patterns, right? And again, you're seeing the end result, just showing one example of this, but this is all throughout my original code of taking what was left over, looking for patterns, just, brute force method, and seeing what could kind of be lumped together into another category. And then once I did it, I would apply the category and then, lather, rinse, repeat. Having done that for a time, I realized I was down to these categories. You've got alcohol other, alcohol permits, animals, vermin. electrical, exterior of the building, fencing, fire, interior of the building, landscape, occupancy, plumbing, sales, short-term rentals, signage, vehicle waste, and then you've got some that are still blank. And so, yeah, I got tired. And I ran out of time. Let's not kid ourselves. And so eventually I said, okay, everything else, we're just going to throw it in a bucket and call it other. Mostly that was because they were the edge cases. Either they didn't warrant a category of their own, or to put them into a category, I was going to have to like write a special case just for it. And it was just like, you know, there's like 100 of these that I would have to do that for. It just wasn't worth it. So I just dumped them in a bucket and said other. Then we just, you know, just do a quick spot check. You can kind of see if you're looking at things like, for instance, the violation description category or a column says exterior prop, right? So you've got exterior prop, exterior prop. What kind of categories would those fall into? And you can see some would fall into vehicles, some would fall under fencing, talking about structures there. Some didn't fall into any category. And so you can see there's, you know, kind of a nice mix there, animals and vermin, road and harborage. So once I was able to kind of dump all of those into categories, then the next thing is taking those categories and applying them to the actual violations themselves. And so this is where I was glad that I had actually pushed pause on this and just started dumping things into buckets and actually getting ahead on some of my homework because I was watching some data camp videos on natural language processing, which is something Mary had assigned to us, and realized that they had really a ready-made set of code there for us to be able to classify things based on the words that are in the descriptions. And so I stole it, basically. I stole their code and used it, but I'm giving them credit on film right now, so that's okay, right? And so what I'm getting ready to show you, this code, it gets busy pretty fast, and it gets very deep, and like I said, it's pulling from packages that have functions, and there's a lot going on in those functions. So I'm just going to kind of give you a high level of what's actually happening. What's actually happening here is when you take this data, and you look at this column, the violation description column, you see a lot of these words here, right? And if you were to imagine teaching someone, like teaching a kid how to do what you're wanting the computer to do, how would you do that? You would take that kid, right? Because the kid would have no real contextual knowledge of like, what is a violation, you know, what are these laws? They wouldn't really understand. They could read, they could see the words, they could count, but that's really about all a kid can do. And that's about all a computer can do too, so it works out well. So if you were to take a kid and say, I want you to categorize these things based on what you see here, right? If you had a pretty smart kid, this kid would say things like, well, every time I see a phrase like, for instance, let me come back up to here. This is landscape, right? It would look and see, oh, high weeds. That's a landscape, right? This has already been told for me that this was a landscape category. High weeds, landscape. High weeds, landscape. So guess what? If I see a code violation and the thing says high weeds in it, that's probably a landscaping, right? It's a high probability that that's going to be a landscaping violation. That's how you teach a kid. And so that's exactly how you teach a computer, right? It takes the words, splits out the words, and just starts counting words. And the more times it sees that word and sees that word being associated with a category, the more likely it is that when it sees it out in the wild, it's going to assign it to that category. So that's the like way broad overview of what's happening here. Except we had to teach it that. Okay, and so to teach it that, what we did was we took these laws that had been categorized and we trained our model on it. And the way we did that is, come back down here. The way we did that is we took and we tested it on 1/3 of our data, which means 2/3 of our data was used to teach it. Right? So you take 2/3 of the laws just at random, pick 2/3 of the laws, and show it to the computer, and the computer says, oh, I'm doing word counts, and I see when these words are being used this often, it's being applied to this category, so I learn that association. Then you take the other third of the data and you hand it to it, and you cover up, the, as it were, the category. And you say, here is the description, tell me the category. And it goes through and it predicts all the categories. Then you uncover and say, okay, here's the right answer, here's the answer key, and we compare it to what the computer actually guessed, and we see how it matched up. And we get a score, right? It's just like going back to school. So that's what all this code is basically doing. And so you can see here it's making prediction. We have trained it. We have used it to predict. And then we've come up with an accuracy score. And then we've also come up with something called a confusion matrix. And the confusion matrix, I'll show you in just a second, is a way for you to see this is what the computer guessed, this is what the right answer was, and what did it get right and what did it get wrong. And not only what did it get wrong, but how did it get it wrong? What did it choose? So that you can kind of use that as an iterative process to retrain your model and make it better. So when you see this, right, I ran this through, and my program here was able to score at about 82% accuracy, which is pretty good. And in fact, you don't want it to be too good, because if it's too good, that means you've probably overfit your model, which means that it's really good at memorizing the test questions that you give it, and it could answer 100% on those test questions. But if you give it something anywhere worded slightly differently, it just bombs, right? And so you don't want to overfit your data. But so 82% I felt like was a pretty good first pass. And then you can see the confusion matrix here, which is a little confusing because you can't see it all at one time. But I'll try to explain it. The rows are what the computer actually categorized them as, and the columns are what it should have been, right? The right answers. And so you can see here, signage, it chose 16 laws to be categorized as signage, and that was the right one, right? One time it got it wrong. It said it should have been signage, but it should have been categorized as an other or miscellaneous, okay? And so you can see the diagonal, those are all the correct responses or the correct categorizations, and anything off the diagonal, those are ones that it got wrong. But you can also see, why it got it wrong. And so we won't take time to dive too deep into that, but you can kind of look through and see some interesting things. And again, this was an iterative process too. It took me a few times of going back to my categories and recategorizing things to try to get it to be pretty accurate on things. We'll skip that. So, well, I won't skip that actually. So you can see the precision, that's the number of true positives. So the number of right answers here, the percentage on each one. And so you can see alcohol, other, it got right most of the time. Alcohol permits, not so much, right? Occupancies, not too bad. Short-term rental, it didn't do well at all for various reasons. And so my model was okay, but certainly could stand to be tweaked a little bit. Okay, so we had the categories, we've got the model now, we've trained it, and so now we're going to release it, unleash it on the violations data itself and see how good it is at categorizing things. So what we did was we pulled in the violations data, and I'm going to show you that in how we got it originally. We got a CSV just chock full of gobbledygook to my eyes anyway. And so it's really hard to tell what's going on here. This is just a comma separated values, put into a text document. So when you pull that into Excel, things look a little nicer. You can see the actual columns here. And so you can see we got the date it was received, which I should point out, we received data, I believe, from October, the first part of October of 2014 to first part of October 2017. So we've got about 3 years of data going up until October of last year. So you can see the property address. You can see the owner. Hopefully you don't see your name there. You can see the complaint source. You can see the reported problem. So this is what was called in. You got your couch in the front ditch. That's pretty standard for where I'm from. I'm from Shelbyville, by the way, not here. So anyway, then you've got the actual violations noted. And I want you to take note of this column, because when you look at this column, these are what the inspector or whomever actually saw when they went out there. And you can see they're kind of written in a way that looks very similar, right, using a lot of the same words as this guy right here, the violation description. And so that's what we used. We used the violations noted compared with this violation description, because that was the best, correlation between those two data sets to be able to make those predictions. And so what did we do? Well, we pulled that in. We cleaned it up the same way we cleaned up the other. We needed to convert things to uppercase in that column. We needed to drop the records that had no violations noted, because a lot of times you would get a violation called in, but then by the time the inspector got out there, they wouldn't see anything. Either somebody cleaned it up real fast, or there wasn't a problem anyway, you just had an ornery neighbor. And so you would see a lot of null values in that violations noted spot. And so those don't have a category, so those need to be thrown out. And so we dropped all those and pulled that into Python here in our Jupyter notebook. And so you can see all that data being pulled in, but you can now see the violations noted category there in all caps and full of values. So now what did we do? We ran this data through that model. We already had the model built, and so now we're just running those data points through that model and asking it to predict. And so there is a little bit of a wrinkle on this. When we went to predict, I decided, you know what, I want to see what's the probability, because for every category, or for every violation, what it does is it says, okay, let's look at all 18 categories. Which one is it most likely to go into? And based on its calculation from the model, it would come up with a probability for that violation being in each category. And what I wanted to do is say, okay, you know what? If it's not at least 75% sure that that violation should be put into a category, then don't put it in there. And in fact, if it doesn't find anything, then just don't categorize it at all. Because for this data set, it's not that big a deal if you miscategorize necessarily, but I do want to have some sort of standard of like, you need to be at least so sure. If you were doing this for like cancer research, you would want that number to be a lot higher if it's a cancer or not. You want to be very sure before you start assigning things as cancer or not cancer, so you would put a lot higher threshold there. So once we did that, we came down and just to show you those probabilities, these are in scientific notation, so these are actually really small numbers, but you can see, oh man, the formatting. This guy, that's 9.8 times 10 to the negative first, so that's really 0.9845. That's a really high probability. So whatever I don't have the labels here, but whatever category that's corresponding to, that's the one that this first the first violation got assigned to, was that category. And so then I just said, all right, let's just fill them all in, right? Stick all those predictions into that violation category column that I had created. And then we just take a look. And when you take a look, you will see here the violations noted column, and then here's the violation category that got assigned. And so you can see high weeds, landscape, open storage, junk, trash, debris, that's waste. Parking on grass, that's a vehicle violation, right? And so as you kind of come on down, you'll see when you get weird things, it didn't know what to do with it, so it left it blank. And as you just come on down, you just see it works pretty well. Now, it's not perfect. Just to kind of show you, if you got something in the violations noted having to do with animal like dog, well, let's see. Dog excrement, I got nothing. Right? For whatever reason, my model did not like classifying any kind of dog excrement. One time it was bold enough to throw that in there, but or two times. But most of the time it didn't know how to handle that. So the model's not perfect, and certainly there are many things we could do to tweak this and have it run a little better. But certainly that gets us well down the road without having to manually go in for 50,000 violations over a 3-year period and try to assign, with a human, go in and assign a category. Even though this took me hours to do because I didn't know what I was doing at first, for someone who's somewhat skilled at this goes pretty fast and is able to categorize quite a few in a very short amount of time. So the question is, what do you do with all this data now that you got all these categories? And that's where Mahesh comes into play, showing us some of his really awesome visualizations.
Thank you, Evan. So yeah, as Evan mentioned, I took the data that he generated, all the classifications for all the violations, and just got the chance to ask some questions. Why is this not going? There you go. Oh, it's going now? No, not going now.
Yep.
Okay. I was lucky enough to just be able to ask some questions and say, all right, what do we see? So this would be the exploratory data analysis part of the data science pipeline. And this is not just a blank screen. So basically, I was just asking myself for all of these smaller questions, what can we see from the violation categories that Evan attached to all the violations? And so I'll just walk you through a little bit about some of the interesting things that I found throughout the data. Just really quickly, I wanted to go through again and see what the data looks like. So this is just the top few rows of the data set Evan walked through. And so just as before, as he showed, there's a category that he assigned to each of the violations. And within this, there's a few other pieces of information that I wanted to pull out for further investigation. One is the latitude and longitude for each violation, just so we can see where the violations are occurring. And also a little bit possibly more informative, the council district where the violation occurred, and the date received to see when the violation occurred. So I'll approach all of these different bits in some of the questions and visualizations that I went through. Just kind of like broad strokes, what's happening with the data. These are all the categories, and we went through, or asked the computer to go through and count how many violations fell into each of these categories. And you can see the vast majority fell into waste and vehicle and landscaping. And as you go down, there's fewer and fewer into each one. One thing that I thought was interesting is that the most violation laws were about alcohol, but there were actually relatively few violations noted or reported about those. So it seems like the majority of violations have to do with waste, vehicle, and landscaping. And so the first question that I asked is, where do these violations typically occur? And so to do that, I used a package called Bouquet. And one thing that I like about it is that it's able to produce a very nice visually appealing map to show where all of the points occur. I'm just resizing this. And basically what you're seeing here, outlined in black, is Davidson County, and all of the points on here are the different violations. And you can see the legend here showing which violation the colors correspond to. And so you can see, in general, just where all the violations occur. One thing I like about this map in particular is that you can click on different parts of the legend, and it will remove or add different parts, different violations that were noted. And so if we get rid of a few of them and leave some violations here, which in green is signage, you can see different patterns emerge. What I found was interesting is that it seemed like many of the signage violations appeared across these arteries throughout Davidson County. And so this could be something that, if you want to know where violations about signage typically occur, here's a pattern that you might be able to follow. So this is one thing that we were able to use to show spatially where different violations occurred throughout Davidson County. I did the same thing looking for, instead of the violations, how the violation was reported. And so this is the same kind of map showing Davidson County and the different violations, but in this case, the color corresponds to how the violation was reported. And so this could be useful in a variety of different ways. And one thing that I thought about is maybe you can see if particular areas report violations in a certain way. And so one thing I noticed was down here, you see this kind of grouping of pink dots, and that corresponds to neighborhood groups. So this area, Davidson County, likes to report violations with through their neighborhood group. And here you might see like a cluster of purple dots, and that corresponds with Metro Council reported violations. And so this is just another way that you can see how the data spatially are spread out, where typically violations that are reported, see if they group together in any particular way. So beyond spatially looking at how the violations were grouped, I just kind of grouped them in a different way. And so one thing that might be useful is looking to see across council districts if some council districts have a much higher level of violations or fewer or a particular type of violation. And so that's what is shown here. So this is what's called a stacked bar chart. On the x-axis are all the different council districts. On the y are the number of violations. And each color in the bar corresponds to a different violation category that I've been assigned. And so, for example, in Council District 28, you can see by a hair it has the most violations reported. And it looks like the top 3 categories correspond to waste, vehicle, and landscape, which isn't surprising. That seems to be the highest for most of the categories here. But if you're interested in a particular council district or a particular type of violation, you might be able to say which council districts have the most types of violations occurring within them. So this is just kind of a different way of grouping the data. One thing that I ended up being very interested in was to see how the violations changed over time. And so this graph was actually pretty interesting to me. And so you can see here on the x-axis is time over the time scale that we had all the violations, and on the y-axis are the different violation categories. And the dots here just show when the different violations occurred. One thing that really struck me was landscaping. And you can see it has this cyclic pattern with it, where there's a bunch, like a high grouping of landscaping in, not surprisingly, the spring and summer months, and then it kind of tapers off and goes to a very low number of violations in the winter months, and then it jumps back up pretty quickly. And so if you're interested in maybe resource allocation or when you can expect the most landscaping violations to occur, maybe this could be, we hypothesize that a lot of the violations would occur in a maybe not the entire year, but in just a narrow window throughout the year. Also, one thing Dr. Mace pointed out was that an interest in short-term rentals. And you can see short-term rentals early on in the data didn't really appear to be many violations, but starting about mid to late 2016, the number of violations began to tick up, and more recently there have been a lot more violations reported about short-term rentals. And so looking over time, you might be able to see how the contour of violations that are reported change over time. And then one question I had was if there are repeat offenders. Are there certain locations where there are a lot of violations reported, or is it kind of just even throughout? And so that is what is shown here. So this is a histogram showing at each showing the number of violations at each location. And so on the x-axis here shows the number of violations at a given coordinate pair. And then for that coordinate, for each of these different groups, number of violations, how many fall into that category. And so you can see here that most locations have only one violation recorded. And I want to point out this Y scale here is in a log scale. Basically all that means is the vast majority of points fell into this only one violation at any given coordinate, but it kind of muted some of the other higher numbers of violations. So to make it easier to see this, I essentially kind of compressed the top level of this scale, so the bottom ones were a little bit more apparent. And one thing that stuck out to me was this one all the way to the right. And I just asked myself, what is going on with this location here? It's only one, but it has 23 violations reported. And so this really piqued my interest, and I was like, what is happening with this? So I started to dive into this coordinate points a lot more. The first question I asked was, is it only one type of violation, or is it kind of spread out? And so again, I looked over time, and this is just showing the violations that were reported at this location. And initially it starts with one violation that was grouped in the exterior building category, a few waste violations reported. But then more recently, the number of violations ticked up, especially with the interior building, and then others and some fire violations occurred. And so it's kind of spread out. There might be a little bit of a temporal aspect to this as well. But this was very interesting to see for this property as well. And now I was trying to build a story in my head, and I'm assuming, okay, maybe there's just this neighbor that really doesn't like this person. So I'm just going to pick on every single thing this person has going wrong. And so I assumed if it was one person reporting, they might report everything the same way. And so this is showing a graph showing how the violations were reported. And on the x-axis are the different ways that it was reported, and then the number for each one. And you can see the majority of violations were reported by phone. Some were inspector reported, and some were reported by email. This could mean an ornery neighbor, or just, you know, I wasn't entirely sure. This wasn't super informative, but it was interesting to see that how the violations were reported. So I thought maybe instead of looking at it that way, it's possible that this was just the same violation that was just reported multiple times and it was just never resolved. So I looked to see how many violations, what the status was for all the violations that were reported there. And you can see the majority of them are classified as done or closed, which means resolved in some way. Only 1 or 2 were still left open. So these are different violations reported. And so this property, for whatever reason, is like having a lot of issues. So I kind of built up a little bit of story in my head, and I'm like, all right, where is this property actually located? And so this is a map of Nashville, or it's actually just a map, but it's zoomed in on the, when it loads, okay, maybe it won't load. But you can see here, this is Nolensville right here, Nashville Software School, where it's about right here. We're up off the map over here. And so you can see it's a little bit further south, and I actually have a link here to Google Maps, which I pulled up previously. This is what the property looks like, so it's a little bit blurry.
Everyone's
but,
nervous.
Yeah. So it's a little bit blurry, but basically what this is showing, to me, it looks like an apartment complex. So there are buildings all around, all painted the same color, blue, and this looks like probably the front office. And so these are probably all violations that are reported. My hypothesis is that these are all violations reported in an apartment complex. And so what was interesting to me was twofold. One, you know, this apartment complex probably has some issues, but also the way that the violations are reported, all of them are reported at this one location, which is pointing at this, what looks like a front office, but most likely they're not all at that front office, or there's something seriously wrong with that front office. But where it's kind of dropping the pin for where the violations occurred, there might be some resolution questions, and so the location may not be fully reliable about the exact location of where the violation is occurring. This might not be the case for houses or other properties, but yeah, so these are some of the insights we had. What I found really useful about this is kind of just being able to ask questions, and when you see something interesting, dig into that and kind of tell yourself a little bit of a story and figure out what's happening. And so with that, Mary will continue with some other interesting insights that we had.
Thank you. So you probably can tell that we had a lot of fun with this data set. It was a deeper dive into a lot of things than we planned for the second data question that we worked on. But for us, it was a fabulous learning opportunity. And for residents, open data combined with the tools and the knowledge to really explore that data is super valuable. It helps us all understand the place where we work and live. And these kinds of insights that we're talking about here can also be really valuable, I think, for your agencies. They can help you plan when you might need temporary contract employees for seasonally influenced inspections or other work. And they can help you spot trends and problem areas before they get out of hand. A couple of months after we finished working on this particular project, I saw this news article, and I was compelled to go back. It really brought home to me, it stopped me in my tracks, because here's this open data set that's being referenced in this news article where a fire had killed 3 people and injured 11 others. And in the article, it states that the owner of the property had racked up 300 code violations in 2 years. And so I was compelled to go back and verify that claim. And so that's what I did. I did a count of owners in the property standards violations data to get the most frequent occurring property owners, and from the 5 X's, you can see the different ways that the owner referenced in the article appears in the data set. And so after some data cleanup, converting the owner to a consistent case, splitting out the last name and the first initial, we get 272 violations where M. Barrett is listed as at least one of the property owners. So kind of just to leave us with some things to ponder, is there a relationship between property owners with lots of violations and subsequent loss? Is there a relationship between the types of violations and those losses? Is there additional data that could be joined to the property standards violations in order to generate a model that would flag properties that should be given additional attention? That's what we have for you today. We're happy to answer any questions or continue conversations.
With all the work that you put in refining the categories, how useful is that to Metro to have these categories put together?
I think it's quite useful in terms of us being able to identify and discuss sort of broadly how to move forward with dealing with different sorts of complaints or requests for service, especially in terms of that breakdown of landscaping and vehicles and waste. I think was the first, waste through vehicles and landscaping. So moving forward, we are still, as you know, actively constructing and thinking about data skills and literacy for our employees. And so one of the things that I want to say our external partners are helping us to do is kind of raise our game in terms of what we can visualize, how we think about it, and sort of helping us to figure out where we need to go and what we need to be doing. So very useful, I think. Do you want to?
So for me, I'm Bill Herbert. I'm with the Coach Department. This is the first time that I've seen this, and I'm fascinated by it. I'm very confident that I am the worst computer person in this room. So I'm amazed by this, but just right off the bat, I can see where I could use this in trying to answer questions for council. I have the breakout by council district is incredibly helpful to me. The breakout by the type of violation is incredibly helpful. It would help us in determining our budget processes for the future on where we need to allocate resources within the department, where we need additional resources. So immensely helpful. And just to summarize it, I want it.
Sorry, Keith.
No, I think this is phenomenal, and I actually, if you hadn't said something, I was going to kind of turn to you and ask you for your opinions, but no, I absolutely agree. It's interesting, you know, this all comes from a standardized system that was migrated from a legacy system that was migrated from another legacy system, and I think the data and the need to clean it like you did kind of shows that. So it gives us certainly some really good starting points on how we go about, and instead of just continuing to live with this, take it to the next level from a data architecture standpoint. So I think this has been fantastic. We really appreciate it.
I work for the fire department, and you know what pops into my mind is you've got your code set and your violations. We've got our code sets and our violations, and surely there's a way where the two could marry, and we can see, because you know we actually respond when things go south in a place that has a lot of violations, has a fire or some other event. So I would think that there would be something that in putting our data with your data and pulling it together, and it might actually make a stronger case for what you take to council and for what we take to council.
And in terms of ongoing public safety, bringing that data together with the fire marshal's office.
Yes.
And maybe maybe they reallocate how often they conduct their inspections in particular areas versus others. And maybe that saves lives.
That, and also when we think about asking for budget for additional inspectors, because, you know, we have such a small number of inspectors and a huge number of inspectable properties. So, and I'm sure you all are in the same situation, so it helps us sell or make the case when we go to council that, you know, we need additional inspectors because we have these issues to address.
So I'll just say that we're approaching capstone season in our first data science cohort. So ideas like this that maybe a student could work on for their capstone project is fantastic if we want to pursue that.
We know who you can talk to.
Is the software school running analysis? I saw great data munging and data visualization, but is it like one step further? Your last slide sort of brought up the question of causation, correlation. Does it go that one extra step?
So we have just started a few weeks ago our machine learning section. We're working on an anomaly detection problem now. Apparently in logistics companies, fuel theft is a big problem. So we're looking at sensor data from trucks to see if we can spot that drop in fuel level. All of that just to say we've just sort of started to get into applying machine learning algorithms to, this was sort of a surprise that we got into a classifier as early as we did.
Could you talk a bit about how the data science bootcamp is structured?
Sure. So like in the slides, we do all of the data science process. So we spend a lot of time focusing on reading in different kinds of data and cleaning the data. We start in Python. We use Jupyter notebooks because they're just super good to use. They're easy, they're nice to get that result immediately. And then after a couple of months cleaning data and really focusing on visualizing data, we go to R programming and we learn R packages, the tidyverse. We learn doing the same kinds of things using a different syntax, and that leads up to their mid-course project. We use Shiny for the mid-course project, which is a web app package in R. And once mid-course projects are done, we go back to Python to start doing the machine learning and natural language processing.
Yeah, so the EDA stuff's both you do during the R period, right?
Yeah, so exploratory
Sort
data.
of worked in across.
So I know that Mahesh called it EDA, but I would really call that the storytelling aspect. That's the insight and sharing the results more than the EDA. You use similar techniques. It's just sort of where you are in that process. Did I answer your question? Okay.
All right, well, this is probably a good natural stopping point. I know we've run a couple of minutes over, but I want to thank you so much for coming. I want to encourage you to stay for a while. We're going to take about a 10-minute bio break. I assure you there are lunch-type bagels. Hardly anybody's touched coffee or soda, so please have something before you go, and we'll reconvene here in about 10 minutes. Thank you so much for your time, and thank you so much to the Nashville Software School for your great work using our open data and getting us exactly where we need to be. Thank you.
It's gone. It's gone.